All the access methods and other attempts so far are in order to classify the endpoint as either a device or a host. If discovery determines the endpoint is a host, then it will continue. Otherwise, the endpoint will be skipped. The end state will be unsupported device, and the result, skipped. Once discovery determines the device is a host, then we move on to collect host info and interface list details. These two methods, along with device info, are critical for proper host identification. Without success in completing device info, host info, and interface list, discovery does not have enough information to feed the host identification algorithm. It's worth mentioning that Atrium Discovery can cope with partial results in these methods, although the identity of the host will be less stable. Access failures will be recorded as no access for end state and result. Common reasons for no access failures are credential permissions, poor edits to discovery scripts, login or script timeout issues, or parse failures. We'll discuss access failures in more detail in upcoming modules. Contact support if you have further questions regarding specific access issues. The host algorithm uses a weighting technique to try to compute a key. If successful, a new host is created. The end state is good access, and the result is successful. The algorithm compares the current properties with those from existing host nodes. If there's a difference and it is significant, then a host key is generated. Otherwise, it uses the closest match. This allows for a certain amount of change, such as upgrading the OS or changing the NIC, without forcing a new identity. Discovery cannot compare every existing host from the data store, so the following candidates are pre-selected for comparison. The host that was previously associated with the endpoint, hosts with interfaces on the same IP as the current endpoint, and hosts that have the same serial number. Once a login credential or a slave has been used successfully, it is cached for use in future discovery of the host. So now, standard discovery will finish collecting details and record them within the DDD. Additional discovery will kick off and will also write results to the DDD. It's important to understand that the end state only relates to establishing a good quality session to the endpoint and relating that endpoint to a new or existing host node. Failures can occur with the rest of discovery, but the end state will not change. So now we'll look at the discovery process again, but this time we'll focus on what happens on the second or subsequent scans of the endpoint. Upon the second scan of the endpoint, discovery makes another check to see if we are allowed to access. If not, the result is skipped. On the first scan, the only likely end state would be excluded. Very rarely, opt already processing, if the same endpoint is injected twice. We'll discuss this later in this module. But on the second scan, the end state can be opt not best IP or opt remote. For opt not best IP, this is where the endpoint was optimized last time, so we assume it will be again and won't contact it. Again, we'll discuss optimization later in this module. However, opt remote will only be seen on a consolidation appliance. This means that the endpoint was optimized on the scanning appliance, so you'll need to log in there to view the full details. Because this is not the first time Atrium Discovery has scanned this endpoint, we'll check to see if there was a credential cached. The reason for this is simple. It saves time when attempting to establish a session. This is one of the main reasons that discovery times are faster on the second or subsequent scans. If discovery does not establish a session, then a full analysis will be needed. If there is success, then OS device classification is the next step. Discovery does this to ensure that this endpoint is really the same host, and not a similar host where the credentials just happen to succeed. So from here on, the steps are the same as those for the first scan. OS device classification, then on to collecting host info and interface list details, and finally, running through the host identification algorithm. So now let's look at what we mean by discovery optimization. You may remember that Atrium Discovery strives for low impact on target hosts. This can be achieved through optimization. Discovery will skip endpoints to improve scanning performance and reduce contact as well as load on the target device. Under some conditions, the same IP address can be requested while another scan of that IP is still in progress. To prevent collisions, if a duplicate is detected, then one of the endpoints is skipped. So in this case, the result would be skipped, and the end state would be opt-already processing. In general, the level of access to a device over each interface is the same. So there's no point scanning the same device several times within a given IP range. So if Discovery finds that a host has multiple interfaces, it will select one as the best to use to update the host. By selecting a best IP, Discovery minimizes network traffic. This will also help to keep the inferred host node stable within the model. Essentially, the first endpoint that provides the good access end state is the one that Discovery will attempt to use. During the first scan, if Discovery has already updated the host with another endpoint, then Discovery will stop. The result will be skipped, and the end state will be opt for scan. But on the second scan, Discovery will check to see if the endpoint was optimized last time, and if so, it will assume it will be again. Discovery stops for this endpoint. A skipped result and an end state of opt not best IP will be recorded in the Discovery access node. But Discovery will not continue to make optimization assumptions forever. By default, Discovery will contact the host on the other endpoints about every 7 days to confirm. And finally, let's bring our Discovery overview discussions to a close. But before we summarize, I quickly want to mention errors. It's highly unlikely that you will get an early error state, as this suggests a fundamental error in the core system. These are usually picked up in internal testing if they do occur. But if an error does occur, Discovery will set the result to error and the end state to the last state that was reached. The most frequent reason for error is the result of an incorrectly amended Discovery script or a custom pattern. As I mentioned at the beginning of this module, we were building up a state chart. So here you can view the complete state chart for standard Discovery. And here is the same state chart with both standard and additional Discovery details. It's important to understand that standard Discovery does not end once a session has been established. Failures can occur for the rest of Discovery, but the Discovery accesses end state and result will not change. And here we've added sweep scan and full Discovery details to our state chart. Notice that a sweep scan level of Discovery will not go beyond device identified or no response end state, as it is only intended for a state survey during the initial rollout of Atrium Discovery. Other scan levels are not included in the chart, as these are the only two that should be used during normal use. Other scan levels should only be used under guidance. So to summarize, endpoints can be excluded from Discovery where needed. Discovery needs to see network ports of target devices in order to select the correct methods and credentials. Atrium Discovery does a full discovery of hosts and a basic discovery of other devices. Discovery caches successful access methods and credentials and performs optimization of endpoints to reduce contact and load of the target hosts. And finally, Atrium Discovery needs to succeed on device info, host info, and interface list in order to create and update a host node. For more information on this topic and many others, please see our online documentation. And for